Good afternoon, everyone. I would like to begin by acknowledging the traditional custodian of the land we meet today and pay my respect to their elder, past and present. I extend that respect to Aboriginal and Torres Strait Islander peoples. Then I pay my special respect to fallen heroes from Spring Revolution in Myanmar. I also like to thank this month AMI presenter, Professor Gordon Lister and Dr. Chikoku. I appreciate all our participants from different parts of the world for joining the AMI seminar today. Our AMI president, Nicholas Goebel, will open the meeting. Nicholas, the floor is yours.
Thank you, May, and welcome everybody to the May edition of Australia-Myanmar Institute's monthly webinars. We have two speakers this evening, both geologists, to talk about how the Earth works beneath Myanmar. As you'll know, there was a terrible, devastating earthquake which hit Myanmar recently, and reports of over 4,000 or around 4,000 people killed, although I suspect we'll never get to know the true number. Dr. Chikoku is our first speaker. He started his career in Australia as an engineering geologist and then moved on to various other jobs. He has multiple degrees and has authored multiple papers and two books. And since his recent retirement, he's been busy giving seminars and lectures, educating fellow professionals and others in Myanmar. He has, of course, a deep and abiding interest in the situation in Myanmar, and we very much look forward to hearing from him today. Our second speaker is Dr. Gordon Lister, Honorary Professor, as I mentioned, at the Sustainable Minerals Institute at the University of Queensland. He too is a geologist and with a PhD in geophysics. He's explored the deep workings of the India-Asia collision, as geologists call it, including building models as to how things look underneath Myanmar, including up to depths of over 100 kilometers, and how things have evolved with time. And he's currently involved in exploring the links between giant earthquakes and giant ore bodies, which is one of the stranger aspects of how the Earth works. But without further ado, may I invite Dr. Chitko to kick off for this evening's webinar. Thank you.
Thank you, Nicholas. Today I'll be talking about the earthquake hazard and its recent tremor consequences in Myanmar. My presentations, the contents of my presentation will be: what is earthquake, cause of earthquake, global earthquake belts, geohazards caused by earthquake, Myanmar plate tectonic earthquake and Sakine fault, Myanmar earthquake historical records and possible recurrence, recap on Myanmar earthquake hazards, consequences of Manly earthquake, other contributing factors related to the consequences, and conclusions. So if we look at our planet Earth, it consists of inner core, outer core, mantle, and lithosphere. The lithosphere composed of the crust and the brittle part of the upper mantle, which is about 40 to 280 kilometer thick. Earth crustal thickness varies through tectonic region. The continental crust is about 30 to 70 kilometer thick, and the oceanic crust is about 6 to 12 kilometers thick. Earthquake is a shaking of the Earth's surface resulting from the sudden release of energy in the lithosphere that creates seismic waves. The intensity can range from those cannot be felt to violent enough to cause great damage and sometimes loss of life, from a few to incredible number of deaths. So the lithosphere is made up of about 15 slabs called tectonic plates, as you can see it in the above diagram. The boundaries between tectonic plates are made up of system of faults. Each type of boundary is associated with one or three basic types of faults. namely normal, reverse, and strike slip faults. Tectonic plates move a few centimeters a year, but still cause a huge amount of deformation at the plate boundaries, resulting earthquake. So earthquake can strike any location at any time. History shows they occur in the same general pattern, year after year, principally in three large zones of the Earth, known as Circum-Pacific Belt or Ring of Fire. It is located along the rim of the Pacific Ocean. Earthquakes in this belt include the 9.5 magnitude Chilean earthquake, which is also known as Valdivia earthquake in 1960, and the 9.2 magnitude Alaska earthquake in 1964. The second one is the Alpine earthquake belt, extend from Java to Sumatra, through the Himalayas to Mediterranean and out into the Atlantic Ocean. The third one is the Mid-Atlantic Ridge. The ridge marks where two tectonic plates are spreading apart. Most of the Mid-Atlantic Ridge is deep underwater, far from human development. So the hazards caused by the earthquake are ground shaking, surface faulting, liquefaction, and landslides. So this is the second Alpine belt, and Myanmar sits on the earthquake-prone region Alpine belt. This will account about 17% of the world's largest earthquakes. We may remember the 9.1 magnitude Indonesian earthquake in 2004 during the Christmas time, generated a tsunami that killed 230,000 people. That includes Thailand, Myanmar, India, and also Sri Lanka. Following the next year in 2005, another earthquake, 7.6 magnitude, struck Pakistan, and it killed more than 80,000 people. And recently, the 7.7 magnitude Manly earthquake in 28 March 2025. So Myanmar lies on the boundary of three tectonic plates, the India plate, the Burma microplatelet, and Sunda plate. The northwest moving India plate is subducting underneath the Burma platelet at an average rate of 35 millimeters per year. The Sagaing fault is a major fault in Myanmar, which is right lateral transform fault between the India plate and Sunda plate. So looking into Myanmar earthquake history, about 41 earthquake incidents of magnitude 6 to greater than 8 occurred over 170 years. That is from 1839 to 2008. According to this record, magnitude 6 to 6.9 occurred once every 6.8 years, and magnitude 7 to 7.9 occurred once every 11.3 years. And out of these, significant Sagaing fault triggered a large portion of the destructive tremors. So what is a Sagaing fault? Sagaing fault is a fault went through in the middle of Burma all the way from north to south. It is approximately 1,500 kilometers in length, often compared with the St. Andreas Fault of USA. It is a strike slip fault, horizontally moving about 20 millimeters per year. And recent GPS station data reveal a movement rate of 30 to 40 millimeters per year. This fault also has a vertical component displacement, which is estimated between 1,500 meters to 1,800 meters throughout the geological history. About 19 greater than 7 magnitude earthquake occurred along the Sagaing fault over the last 186 years. That is from 1839 to 2025. One occurrence every 9.8 years along the Sagaing fault. Unfortunately, It runs through the major cities and heavily populated areas. So recent Manly earthquake zone has been identified as destructive zone since 2005 and followed in 2016 by Dr. Thing. Actually, Dr. Thing connected all the three high destructive zones along the Zagain Fault. Also, when I look at the other one, the Manly earthquake zone is also identified as high hazard according to GSHAP map, which is produced by Global Seismic Hazard Assessment Program, which closely agreeing with the seismic zone map of 2005 and 2016. Dr. Thay noted the Myanmar disaster ranking order is earthquake as number 1, followed by cyclone and flood. Such findings have been informed and notified long before the Manly earthquake incident through various channels. Yet Myanmar was caught unprepared. So this map is the earthquake focal depth map, contour map, which is the depth of the epicenter. So the focal depth contour map shows that earthquake historically occurs in shallow depth along the Zagain Fault. Majority of historical earthquakes occurred within 10 to 20 kilometer depth along the Zagain Fault. The severity of the damage is said to be higher with shallow depth as ground shaking severity reduces with the depth. Depth of Manly earthquake is just 10 kilometers. So there are some distinguishing features of the Manly earthquake. The magnitude 7.7 earthquake was immediately followed by a magnitude 6.7 aftershock within 12 minutes. Horizontal ground displacement is about 3 meters, more than 3 meters along portions of the fault, with a total offset of more than 6 meters in some places. Estimated surface ruptures of the earthquake is 460 to 550 kilometers in length, with rupture extending from north of Manly to south of capital city Naypyidaw. It is one of the longest documented strike slip fault into surface rupture on record. Described as a supershare earthquake, where the slip along the fault moves faster than the seismic waves it produces, which can concentrate seismic energy ahead of the rupture, causing 3,700 to 5,500 deaths, plus substantial number of buildings, infrastructure, and cultural heritage sites damaged and destroyed. It goes beyond the boundaries. Zagain, significant damage in Thailand. Hundreds of homes were damaged in Yunnan, China, while more than 400 apartments were affected in Ho Chi Minh City, Vietnam. There were 157 aftershocks reported till the end of April and is still ongoing. So this map on the left-hand side is the earthquake intensity map by United States Geological Survey. This map indicates that the intensity is 10 plus, which is described as extreme, and damage could be very heavy, confirming the map produced by Dr. Thay on the right-hand side. So the earthquake intensity is given by the modified Mercalli's intensity scale. It got about 10 levels. That is about 9 is violet. That is 10 plus. So the ground condition agreeing with what the USGS map was saying. So when I look at the fatalities and injuries report, and it is from 3 agencies, So different agencies have different data sets, where SAC reported the lowest, which is 3,700 fatalities and 5,000 injuries. Whereas Nizima News, 5,352 and 7 injuries of 7,000. In between those two were Democratic Voice of Burma's News. So substantial death and destruction in Manly and Sagaing region, Sagaing region, and somewhere in here, Nebido territory, and then in the peripheral of the Shan states, amounting billions of dollar loss. The UNHCR estimated that 17 million people were affected across 57 of the 330 townships. So total estimated damages, according to grade, is 10.97 billion. See, it's about almost 11 billion, which is 14% of Myanmar's GDP's 2024-2025. So recapping Myanmar earthquake hazards, Myanmar sits on the Alpine earthquake belt. Major destructive earthquakes occurred along the 1,500-kilometer long Sagaing Fault, with movement rate of 20 to 40 millimeter per year. Historically, magnitude 7 earthquake occurred every 9.8 to 11.3 years. Earthquakes along the Sagaing Fault are mostly associated with shallow depth. Thus, the intensity can be severe and on some occasion violent to extreme. A 6.7 magnitude aftershock within 12 minutes would have exacerbated the initial destruction, causing more deaths. The supershare, which can concentrate seismic energy ahead of the rupture, would have contributed excessive destructive force. Finally, Sagaing Fault passed through the major cities and heavily populated areas along the Irrawaddy River basin. So this is the consequence table of the Manly earthquake, which I compare with the military coup. So if we look at the fatalities, the maximum is 5,300 something. But military has killed 6,231, which include 1,100 females and 700 children. The earthquake has destroyed 55,000 buildings, according to writers, and 103,000 buildings were torched or bombed by military. When you look at the health centers, earthquake destroyed 300 and military destroyed 352. As for the schools, the earthquake destroyed a lot more than the military. The IDPs or the homeless, according to writers, there are 200,000 homeless people after 1 month. As for the IDPs, it's 3.5 million. Affected population, UNHCR said 17 million for the Manly earthquake. And this is my figure. The affected people is more than 50 million in Myanmar. So humanitarian aid needed for 2 million earthquake victims, whereas 20 million for the military coup. As for the imprisonment is not applicable, but the military has imprisoned 20,000 prisoners of conscience. So according to Wikipedia, Myanmar GDP was 81.26 billion US dollars. That was before the coup. And 64, I couldn't see the other part of it, billion in 2024. That is reduction of 16.32 billion US dollars. So it was reported that SAC did invoke emergency rescue plans immediately after the Manly earthquake. However, there was no mobilization of the forces, and even After more than a month, there are still dead bodies yet to be retrieved. I got it wrong, as that was not Reuters, it is Al Jazeera. In fact, 196 airstrikes and 64 incidents of shelling were carried out, resulting 235 dead, 427 injured across the country, including the earthquake-affected areas between 28 March and 23rd of April. Emergencies aid have been blocked by areas such as Sagaing as well as Magui by SAC. So there are other contributing factors to the consequences. And there is a saying, death is caused by the collapse of building, not earthquake. So Myanmar Building Code was first introduced in 2016. Apparently, majority of the pre-existing buildings are more likely to be substandard. A significant portion of buildings are considered highly vulnerable to earthquake due to weak construction practices and inadequate enforcement of building codes. Obviously, many buildings collapse, resulting substantial number of deaths. There is the Myanmar Action Plan and Disaster Risk Reduction 2017, which hasn't seemed to be implemented. Lack of will, compassion, empathy, and failure of immediate emergency rescue action by SAC within the crucial 72 hours window definitely caused additional unnecessary deaths. Understand that 40 billion kyats have been put aside for emergency disasters relief fund, and a rescue helicopter has been purchased by the elected civilian government that was abused by SAC. So, as in conclusion, I would like to conclude that it is unfortunate that Myanmar lies in the earthquake region and have to live with it as long as Myanmar exists. Natural hazards such as earthquake disasters may have horrible outcome. As for Myanmar, man-made disasters is a lot worse and disgusting. Earthquakes didn't kill, then who is responsible for the death? We can only manage and reduce the risk, as we cannot totally eliminate the earthquake hazards, as it will always be there. As for the man-made hazard, we can and must remove it altogether. Myanmar would have managed the Manly earthquake disaster immensely better without the military junta. Finally, I'm confident that Myanmar will get back on its feet again soon. Thanks for your attendance. Hope that all of you will enjoy it. Have a good day. Any questions?
Thank you, Siache.
Yes, thank you very much, Dr. Chitkoko. We will take questions at the end, and I should mention that if anybody has a question, please put them in the chat box, and then we'll get to those after our second speaker, who I mentioned is Professor Gordon Lister. And Professor Lister, if you're ready, we're happy to hear from you now.
Okay, thank you, Moshe. So our talks fit together very well. I'm concerned with seismotectonics, which is really about the movements that cause earthquakes. And partly my interest is it's one of the most difficult problems we can tackle, and many people just don't think we'll ever get to predict or even forecast accurately what happens with what determines when an earthquake happens. There are so many things that we need to do. We need to understand the physics. We need to understand the geology. We need to understand the movement, which we can do with satellites. And we need to understand the architecture. We've got a Rottweiler here who wants to contribute. The geological architecture is critical, and I'm going to talk a little bit about that tonight. just to show you a little bit about Myanmar and how the Earth works around Myanmar. But one of the things we really try and do, before I get too far into it, is I'm just trying to move the doesn't matter. You know, what happens after an earthquake? It's a terrible thing, but we also need to look at it as we would as an engineer. And when a building fails or a bridge, we go and look at it and we try and work out what was the weakness, what was the thing which caused the building to give way. And so when there's a terrible earthquake, we can look at the structure of the region, and then we can assess that that structure, and then we can start to look for controlling structures which cause it to fail. Right? We know it failed on the Saigon Fault, but why did it fail on the Saigon Fault? And why do they always seem to start around Mandalay or in the north and move to the south, right? So there's basic things about if something breaks, it's bad, let's go and look at it and try and work out why. Physics. It's very simple. There are movements taking place on the Earth. And the outside part of the Earth is elastic and brittle. And as it goes deeper, at about 10, 12 kilometers deep in the Earth, it starts getting warm. Well, it's getting quite warm. And the rock starts to become more like putty or syrup. Okay, so the net result is that in the continental crust, at least, where the strongest layers are, is about 12 kilometers, 15 kilometers down. And as movements take place on faults, I've just drawn a simple block being towed along by somebody with a spring. The rock stretches and stretches and stretches until it's got a whole lot of energy stored in that spring. So that when finally there's a break, all of that stretch in the rock, the stored elastic stretch energy, we call it, is released, and that's what causes the earthquake. We know a lot more about how these earthquakes happen now. For example, not my work, but I can provide references to those who are interested in it. We know how much energy comes out, and we know that's from the stiffness of the rock. It's from the area, or how long the area is that broke, and then the actual point at which failure took place. And the thing called moment magnitude is what we use to measure the energy of earthquakes. And the moment magnitude for this earthquake was quite low compared to the length of the earthquake, which was well over 400 kilometers. It was more like 500, and some people are even pushing even higher. And that's because it was a super shear earthquake. The fracture moved faster than the speed of sound in rock, faster than the seismic waves can travel. So not true that there's a pressure build up because of the seismic waves. The fracture is running ahead so fast that it's like it's way ahead of the shock waves, and then these start emanating. We know it broke first. Where it breaks first isn't really where it breaks first, it's where it starts moving so fast that the ground starts shaking. At depth, we call it a hypocenter. Its map position, we call it the epicenter. But all that means is where it starts to release the energy. And in a few 10 or so seconds, moving at about somewhere between 4 to 6 kilometers per second, it was moving down 400 kilometers to the south of Burma. But it didn't break in one go. All those little patches we know now, it broke in several patches. And then one patch would start growing to the north as well as running rapidly to the south. And before it had even started running, another one broke, right? So the actual earthquake is just a sequence of very large shaking events emanating from these different rupture positions on that fault plane as it breaks. Okay, so that's the physics. We know lots of things about the energy, but look at it in terms of megatons of TNT, which gives you a feeling for how big. Like 7 is only a half, but by golly, by the time you get up to 8, you're looking at 15 megatons. There's evidence beginning to emerge that the seismic moment estimated in the classical methods is underestimating the magnitude of energy coming out of a super shear earthquake. And there's papers already appearing that suggest that the energy release was much more than a 7.7 would expect. But think about it in terms of energy compared to what happened in Banda Aceh on Boxing Day 2004, where a gigaton of TNT energy was released. Okay, so by the range of terrible earthquakes, it's a terrible earthquake because it ran through a place where lots of people were living and wreaked terrible havoc. But it's nowhere near as bad as the giant megathrust earthquake that caused such enormous loss of life in Banda Aceh, 250,000. It really comes down, as Chit said, to where people live, the lack of early warning systems, the lack of education as to what to do. Other countries have learned to live with earthquakes. There's no doubt that Burma can as well. Outside of Burma, the diaspora could well take on the job of starting to work out a plan to increase the education level and early warning systems, which are not so hard to implement. Chile is a good example of that sort of stuff. Earthquakes are fractal. We as humans love to think about normal distribution. We would like an average, right? We'd like an average, a recurrence time of an earthquake. We would like an average size of an earthquake. We'd like to know everything in terms of a 100-year flood or a 200-year flood. Those statistics do not apply. They are totally irrelevant. There is no such thing as a recurrence interval. It just doesn't happen that way. We will not get, sorry, Chit, an earthquake every 9.8 years. That's not the way it works, right? So earthquakes run on 1/f noise. After the seminar, if you're interested, type in 1/f noise into Google and you'll be reading for days, right? The other thing about earthquakes is they're log normal. The number of small earthquakes is very, very large, and the number of very large earthquakes is very, very few. For example, Melbourne is shaken by magnitude 1 earthquakes that are 200 or 300 a day. You just don't feel them, right? In Greece, in January, they had nearly 10,000 magnitude 2 and 3 earthquakes to do with an earthquake swarm, right? What happens as the size goes up, they become much more infrequent. And then the other thing about earthquakes is, like all fractals, they're self-similar in their behavior. Okay, so I'm going to look at it from the point now of geology. So we're looking at the earthquake starting near Mandalay and rapidly breaking the Saigon fault in a super shear event with these overlapping fractures, one after the other, and causing the damage because of the amount of soft sediment, which makes things shake worse, and because it was actually a fairly large earthquake. It may have even been an 8, based on the new energy estimates that are happening. What do we see? We see India on the one side, we see Southeast Asia, and we see the Tibetan Plateau. How do the movements work? Well, we have the movement of India north at about 2 to 3 centimeters per year, depending on where you are. Okay, so that's pushing into Eurasia. So India is ramming China. The net result is that we thicken the crust in the Tibetan Plateau, which isn't plate-like. It starts behaving more like creme brulee or stiff syrup with a crust on top, and it gets to start sagging south. The British surveyors showed that the arc of the Himalaya is almost a perfect small circle, which can be explained because the Tibetan Plateau behaves like syrup. And as it behaves like syrup, it spreads, and it's spreading over the advancing Indian plate, and of course pushing down the Ganges basin. Okay, at the same time, we're running everything else north, and so the Saigon fault is one of those boundary faults of the Himalayan collision, and that fault runs all the way up to the mountains called Namche Bawa, which is where the flowing motion overcomes the advancing motion. And you can see the Saigon fault is all bent, and it's bent because you're crunching into that soft syrup. Now, if we look at the movement picture is actually more complicated because there's an active subduction zone where the Indian lithosphere is falling back into the mantle, right? And as it falls in, it doesn't stay stationary, it's actually rolling back. So that line to the north, which I've got as a yellow arrow, is a tear fault in the mantle, and that will tear all the way to Sri Lanka, right? So that subduction zone is going to roll all the way back to Sri Lanka, pulling Myanmar with it. So come back in 10, 20 million years, and you'll be down around Sri Lanka. Okay, that's one part of it. And then, of course, as we're pushing to the north, we're making other big faults which make earthquakes. But that's only part of the story. If you go and look up into the Tibet's not flowing north. Tibet is basically trying to get out of the way, and the syrup is escaping to the east. And I've only shown you where it's escaping, coming down towards Myanmar, but you can see the mountains suddenly drop in height, and that's because where the syrup isn't the subcrust isn't escaping. But now the motion is southwards. And then when you look down further, and we can see the motion actually turns around and is heading westward, right? So because of the position of Myanmar, it's actually like a giant Gaia, a vortex, turning clockwise as you look at it from space, as India continues its motion north. And it's that Gaia which is pushing the cyclone fault continually westward, which means that the cyclone fault can never, ever become just stable movement without anything hardly happening at all. It's always being pushed into a situation where somewhere near Mandalay or north of Mandalay, it's going to break and go bang yet again. Okay, so that's the picture of movement in Myanmar, a giant vortex. You're the bystander to one of the great collisions on Earth, and that's why you get so many destructive earthquakes, which will happen. And one can say that it's very difficult to get very large earthquakes on strike slip faults, but magnitude 8 is very large. But the active subduction zone to the west is quite capable of generating a destructive earthquake of the magnitude that you've seen in the 2000 earthquake. Okay, so you have the capability of two very big types of destructive earthquakes. Okay, so there's the eastern syntaxis of the Himalaya. Syntaxis just means where the mountain ends, and just in the point of where the T is, everything is rotating around in a big clockwise Gaia of motion in the subcrust. Okay, you can see that motion in earthquake patterns. We can see the directions in which earthquakes break. So you can see the cyclone fault is in gold. You can see it's got north-south slip. But just to the west, we have earthquakes which are moving west, and just to the east, we've got earthquakes which are moving west, right? Because of that giant Gaia in the flow of the crust. Okay, so you can see India moving north, the compressional earthquakes in red at the edge of the Tibetan plateau because the syrup is spreading and it's breaking the rock as it spreads. And then underneath Tibet, the rock flowing to the west and then to the south and then back to the west. In the satellites, we can still see the same thing. The motion of the satellites picks up nicely the Gaia that I was showing you about, but it doesn't pick up the long-term motion. It just shows you the modern motion, what's happening now or in the last few years. When we use seismic waves to make pictures of what's beneath the earth in tomograms, a bit like an echoscope in a hospital, we can see where the cold slab is sinking into the mantle. We see the Indian plate is actually sinking beneath Burma in that big ripping back, rolling back slab. And so what's happening as we go with time, up in the left top, we have back a long time ago, the slab begins to tear and the edge begins to sink, right? And that's essentially the beginning of the motion that drags everything west. But then that slab tears in transverse rips in the diagrams beneath, and each of those rips makes a place where fluids can come up to the surface and make giant mineral deposits. And so Burma suffers because of earthquakes, but it also is rich because of earthquakes, because you have very large mineral deposits that people would try and explore more carefully if the situation ever became less politically fraught. Again, you can see those tears developing with time, not so much detail. And here's a picture of the slab, which was made by my student, Nindung Nakron. Oh, I don't know why that's happening. Who's now at Mahidol University in Thailand. And you can see the slab going down to very great depths. Okay, so we see the slab back 50 million years ago as we're pushing in. The edge starts sinking in, and you'll see the line which got the arrows on it, which is the subduction zone rolling back, and now it's rolled over the slab, and that's why we're getting that complicated earthquake. Okay, this is the cross sections of the 2004 great earthquake, and it's basically got exactly the same geology as what you have in the west of Burma. So you will get those sort of large earthquakes. Whether you get such a big one is a matter of conjecture. Probably not is the answer, but you cannot exclude the possibility that you will get magnitude 8s or greater because of that sort of earthquake. You can see why the loss of life happened from the picture of the waves taken from space in the 2004 earthquake. And you can see that those sort of waves would cause loss of life around the coastal areas. But you don't have the same risk from tsunami as you do further south. But you do have the risk of a megathrust earthquake. The danger in the way people portray earthquakes on the news is they show the epicenter and everything coming from the epicenter. That's not how it works. That rupture grew really fast, really quickly. And, it's down quite close to Bangkok before more than a few seconds have passed. And you can see the energy radiating out. Earthquake Insights, if you want to learn more about earthquakes, sign on. It's a very good source of information. And that's the sort of information these people have produced, showing all the main shock, near Mandalay, and then propagating rapidly to the south. Now, while we've got that diagram there, look at Monya, which is a big deposit of porphyry, right? Many millions of dollars will come out of that mine if it's ever mined properly, because deep underneath you've got the slab tears I was telling you about. Okay, pictures of the Saigon fault with the break, the speed. As Chet said, it was a super shear, but that's just the modern fault. If you go and look back in time, you can see the big tears in the slab underneath, and those slabs, as they tear and fall back like ribbons, they suck the earth with them. So from time to time, the motion caused by the falling back to the west winds, and for example, you can see that big circle describing the Gaia, and you can see that big fault through Myanmar, just north of Mandalay, which is rotated in a anti-clockwise sense, right? Because for a while the rocks to the south went westward faster than the rocks to the north, but they did it on a circular fault because of this Gaia, right? So if I take the map of Myanmar from outer space, which is on the left, and I reconstruct it, you can see that once the Saigon fault looked like on the right, and I've taken away that motion. But because this rock got sucked across the Saigon fault, then eventually a new fault had to break. So there are many, many, many hundreds of different ages of Saigon faults as this motion of the Earth drags things across where it would like to break. And then these are the deep earthquakes that you can see. They're all east-west mostly. And that's the other sort of earthquake. Those sort of earthquakes don't cause lots of damage, but they do tell you where untold riches can be found beneath the earth that can help the economy of that country. Okay, and there's the tears mapped out in the pattern. Saying again, right? So can Myanmar learn to live with earthquakes? It must, and it can. Other countries have shown that it can. It comes down to education, number one, so that if you see the thing begin to shake, you react in the, it begins and then it gets worse. You have a few seconds to get under a table, to do something. Early warning, much better, because then when there starts to be shaking on multiple phones, for example, you send it to a central warning system and all the phones start ringing. You can save lives that way. It's been shown in places like Chile. I mean, Chile had the greatest destructive earthquake known in our time. They had a tsunami 40 meters high, right? They lost a lot of people in that time, and since that time, they've learned to live with earthquakes. So some of the more recent earthquakes have not caused the enormous loss of life. And then, as Chet said, better designer buildings. But principally, if we want to do what we can now, when we can, it really starts coming down to thinking about getting education about earthquakes, etc., into schools, and then thinking of simple early warning systems that can begin to be constructed once things come back to a better time for Myanmar. Thanks very much.
Thank you very much, Professor Lister. I'll now open it up to questions, and if people could put their questions and comments into the chat box, that would be greatly appreciated. I might start off with a question to you, to Dr. Chitkoko, or two questions. One's a very simple one. In your chart on consequences, you had humanitarian aid needed, and 2 million after the earthquake in 19.9 following the coup. I wasn't clear. I mean, is that a reference to the number of people who are in need? Or is it certainly wouldn't be the amount of humanitarian funding that's needed. But perhaps you can clarify that for me. The second last row there, it's 2 million. I'm not too sure what 2 million what.
Yeah, you are on mute.
Oh, you're on mute. Yes.
So yeah, all those figures come from different areas or through the news agencies and everything. So I couldn't able to give you the references because I got the references somewhere.
Well, that's all right. I was more curious what it refers to. 2 million people?
2 million, yeah, 2 million victims, Mandela earthquake victims, yeah.
All right, thank you for that.
Yeah.
That was a simple question.
Yeah.
My other question relates to that, the massive surface rupture, and I was just curious. I mean, how does that get fixed? I mean, is that a question of bulldozing soil and gravel into the gaps and filling it up?
I'm not sure. I think it'll be very costly if you are going to fill it up, those things. I think I try to think of the Ava earthquake, which actually it's a capital city of Myanmar in those days, and it has to rebuild I think, in Amarapura, I think they have to move the capital totally. So we do not have pictures or anything because it was a long time ago. It was in the early 1800s. So I would intend to think that that earthquake would have a similar impact as well. But we do not have the data or any information about it. So, but along the fractures and along those things, it will fill back once it rains, right? As Burma had plenty of rain. So even like, I think I remember like the other earthquake, the Beijing earthquake, which was reached to scale about 6.7. And the fractures zone is about 40 kilometers, but not as huge as this one. But I don't think they are there anymore. Because after the rain, it will, all this rain will carry those sediments and then fill it in.
Right. Okay. Thank you for that. We have a question here from Vicky Bowman, or a comment in the question, but I'll read out the question. She asks, and I think it's probably for you, Chitkoko, why do you think most of Myanmar's major cities have been historically built on the fault line? And we think here of Bago, Tohoku, Mandalay, Ava, Yangon, Naypyidaw. Are there other geographical features associated with the fault that favor this as a choice for a city location?
Yeah, this is just my interpretation, okay? I'm not sure whether it will be right or wrong. This is the, actually, not just in Burma. If you look, around the world, you'll see that the major cities are always close to the water. Because there's a Burmese saying, you can't live without the water for 24 hours. You can live without the food for at least 7 days. That's a saying in Burmese. So whenever the villages or cities are started to build on where closest to water, and also if you think of the historical events like hunter-gathering and then farming, agriculture, so it'll be close to the Irrawaddy River Basin, which is this one. This is the Irrawaddy River Basin. So there are a lot of water, a lot of crops, and so all the major cities. And if you look at the population as well, the populations are very low in the Myanmar, where the mountainous areas, because it's away from the water, away from agricultural land, not. So most of the soil will be very good in the delta, for instance. So that's how it is. Like if you look at all and also it's in those. In like 1800 or 1700, it is a lot easier to travel through the water than through the land as well. So naturally, because trade and traveling and everything, it's a lot easier to carry through the water. So all of the major cities will be along the river. And you'll find the same in Australia, I think. If you look at the major city, it's, if you look at Sydney or if you look at Melbourne, or if you look at Brisbane, they are all close to the river. Yeah.
Okay, thank you for that. I have a question also from two questions, related questions from Chris Lamb, and he mentions that it's rather odd that in Bangkok we saw, a major apartment building collapse.
Yeah.
And Bangkok not being on the fault line, Sagaing fault line,
yeah.
And wonders whether other places not on the line have had damage, and can we be confident that the figures that we have seen, the ones that you've quoted, cover all the affected towns and regions?
Oh, you mean in Myanmar?
Yes, I mean, given that there is, in Thailand we've seen damage far away from the fault line.
I think
that's the case in Myanmar as well, and we're just not hearing about it.
Yeah, I think Thailand case, it really stands out, because if you look at the other high-rise building in Bangkok, there's not much damage, right? And the one that has, fall apart, it was nearly finished. So it is the latest building. I mean, I'm just, suspicious that they are not built according to the building codes. That's what I think.
Right.
And so that's the only building that suffered in Bangkok, and it's the latest building. The other buildings that are built earlier, they stand the earthquake pretty well. You could see all the water splashing and everything, but not, totally collapse. And I did ask one of the civil engineers about it because I'm not a civil engineer or a structural engineer. So I did ask him, I think, what is the design is like? Is it design is because it is unfinished, it is falling apart? That's what I asked him. So he said, no, if that finished up to that level, it shouldn't have collapsed. So it may be some design fault. And following the other news from Thailand, I've seen that they are built with substandard, steels and everything. So I wasn't sure. So for Myanmar, I think that's the only thing that happens in Thailand, and one building. So it is anomalous and it just stands out.
Right.
But for Myanmar, I think we may not have the complete set of data. We'll have maybe the data which we have could be reliable to a certain level. I'm not sure whether it's reliable to 70% of it, 80% or 90%.
Yes. I mean, the three sources you gave had quite different numbers. So
numbers, yeah. Numbers, yeah. I tried to look it back because I saw it in different, I followed the other news as well. So I've spent heaps of times on those things just for, talking 20 minutes. And, just to make sure that, my data are, as accurate as possible.
Indeed.
Yeah, but it is very hard, very hard. I cannot say with confidence that, all these data will be, pretty good, but I don't think it'll be very bad or bad.
We have another difficult question for you from Co Salzman. He's asking whether you can share, if you have any information, how the SAC have manipulated international rescue and humanitarian support teams to get international donation funds, and how their action and about their actions after the earthquake. So this is about reports that some of the assistance that's been provided from outside the country, international assistance, is being misappropriated by the military junta. Do you have any information about that?
If you follow the news, the army probably, I think, I'm not sure. There are a lot of news in Burmese news, which is But
you haven't heard from any of
your which is indicating all those things. Even today, I just heard that the military said that every household will be supported 10 lakhs. Those who got, those are buildings collapse or whatever, and that news was saying that they distributed only about 100 or whatever to the close one, and they didn't distribute anymore. So normally what SEC used to do is they have a photograph it, and then they will release this news through their media, which is totally unreliable. In fact, I do not watch this news at all. Yeah. Even 60, 70 years, look back 40, 50 years ago, I stopped reading newspaper because the news are always incorrect. So we only, when we read the newspaper, we just read the obituary. So that's the only correct one in the newspaper, because it's also common. So it is definite, like that they will be abusive. That's for sure.
Yeah.
And if you follow the other Burmese news, you'll find it a lot.
Yes.
But I cannot give you the links, because I do not save those links all the time.
Yeah. We're running a little bit late of time, but I think we'll keep going if that's all right for people. A question from Dr. Raymond Tin Hui, and so it's another one for you, I'm afraid, Chit Koko. Historically, a few earlier civilizations had disappeared, probably related to devastating earthquakes in close proximity to the Sagaing Fault. And although not recorded as far as we know, and he was thinking of the disappearance of the Pew civilization,
Right.
Haringey, near present-day Proem. And he asks, would you have any information earlier than the 19th century related to major earthquakes in Myanmar?
No, the earliest earthquake, I think, we have recorded is 1839. But there are some earlier records as well in 1700s in Rakhine or somewhere else. I think the Rakhine one was recorded by the in those days by the British government probably. So it caused the tsunamis and things. But whether the earthquakes has destroyed the Pew races, I don't think so. Because I think Pew is assimilated into Myanmar. So when we are at the school, we learned that there's a rock scripture during the Anorata time. That rock scripture was written in 4 languages. Those 4 languages were Myanmar, Pew, Mon, and Pali. So I thought in those days, the 4 dominant ethnic groups will be Mon, Myanmar, and Pew. So Pali is just a language, but there's no people who speak Pali in Myanmar, only the monks. So that's, but then I think recently, I think about a week ago, I saw another, he's a archaeologist, and we talk about those issues. And he confirmed that Pew is assimilated into Myanmar. So I hope Dr. Tin will be happy with this answer.
Yeah. Well, thank you very much. And for the answers to your questions. No questions for you, Professor Lister. Your presentation, I think, answered everybody's questions. That's excellent. But thank you both for a very informative talk on a very important subject. It's one which does have a very strong, obviously, technical dimension. And so we really have benefited from your insights, because most of us are not geologists or geophysicists. And it's been wonderful to hear from you about the earthquake, and it has helped improve our understanding of how these things happen and keep happening, and some of the measures which should be taken to ensure that they will have, when they do happen, which they will happen again, that Myanmar should be better prepared for it. So thank you both once again, and I invite everybody to join us again in a month's time, the final Monday in June, for our next AMI webinar. Good evening.